So let's start with systems of linear equations. So we're going to be looking at a few different ways of solving systems of equations. We're going to start with graphing, and then we'll talk about some different algebraic methods for how to do it too. So a system of equations is where you have multiple equations, and what we want to do is see where do these equations match up, or specifically, where do they intersect with each other. So most times our solution is going to be an intersection point, which will lead to an answer that is an XY coordinate. So there are a few different scenarios. Most often it's just the single coordinate, which would be this case where we have one solution. So what this would look like is if we have an X and Y axis, and then we graph, let's say we have a system of two linear equations. What that's going to look like is we'll graph one line, we'll graph another line, and then the answer that we're interested in is that intersection point where those two equations are equal to each other. So that's the common scenario where we have just one solution. We could have cases where there are no solutions, and what will happen there is as we graph these two linear equations, they're going to end up parallel to each other. So same slope, but different y-intercepts. But that just means that they never intersect with each other. And so with that, there would be no solutions because there's no intersection. And then the third case of infinitely many solutions, this is going to come through where we graph one of the equations. And then when we go to graph the second equation, it ends up graphing right on top of the other equation. So this is the case where the two equations are actually the same. And with that, we would have infinitely many solutions because every single coordinate on that line would be a solution to our system of equations. So most often we'll have this one solution scenario, but these are other cases that can come up, and we'll see how these show up, especially in terms of solving algebraically. How do we know if there's no solutions or infinitely many solutions? Well, let's start with graphing. So when we have a system of equations, it'll list two equations like we see here. So we have this y equals 6 minus 2/3 x. And we have this y equals x plus 1. And what we want to do is graph both of these lines. So these are nicely set up for using the slope-intercept. So for this first equation, our slope is a negative 2/3. So I'm going to write that as negative 2/3. And then our y-intercept is that positive 6. So we know we have the coordinate 0, 6. So if I start graphing this, I have the coordinate 0, 6, and then my slope is telling me, again, this is giving me direction, so that numerator, that negative 2, is telling me how I move up and down. Because it's negative, it would be going down 2 units, and then that denominator of 3 is how we move left and right, and because it's positive, it's right 3 units. So that's giving me a map to follow, so down 2, right 3. Down 2, right 3. With these, technically, you only need to graph 2 coordinates. However, I recommend graphing as many points as you can on the grid because that'll be helpful for being really accurate with these lines, which we need when we're solving graphically. So I'm going to go ahead and graph that line there. And there's our first line. Now we need to do the same thing, but with the second line. So y equals x plus 1. So this has a slope of positive 1. I'm just going to write that as positive 1/1. So I can see we're going up 1, right 1 when we follow that trend. And then our intercept is a positive 1, so we have the coordinate 0, 1. So we're at 0, 1, and then we're following a slope of 1. And what we can see is our intersection point. And again, I'm just going to graph as many points as I can just to be really accurate, even though in graphing those points I saw where the intersection line is. All right, so we have our 2 lines, and we might feel like we're all done, we did all the graphing, but we actually need the solution, and that's the intersection point. So right here is a coordinate that is coordinate 3, 4. And that right there is the solution. So we could write a sentence of like, the solution is 3, 4. Now in My Open Math, when you're doing the homework and assignments, you'll follow a similar routine here. So there should be a few different options at the bottom. You'll want to graph the lines first. So like with graphing a line, you just need 2 coordinates. So you could do that intercept and point and have it graph the line, intercept and a second point, and it'll graph the other line. And then there should be an option to select a dot. That's going to get you the answer. So make sure you graph the dot right there if it asks you to. Sometimes they'll just have you graph the line, but it might be an option to graph a dot, and we would want that right there. Okay, so we do this and we should probably check our solution. And to do that, what we would do is plug it in to both of the equations to make sure that we are correct. So we're going to check this 3, 4. So let's look at 4 equals 6 minus 2/3 times 3, which would be 4 equals 6 minus 2, which is 4 equals 4. So it works for one of the equations, but for this to be a true solution, it has to work for both equations. So now we're going to plug it into the other one. 4 equals 3 plus 1, 4 equals 4. Fantastic. So we know with 100% certainty we got the right answer, we graphed those lines correctly, all of that good stuff. Let me show you also on Desmos how we can use that to double check our answers. So on the graphing calculator, we're going to do what we did over here in terms of graphing the 2 lines. So I'm going to do y equals 6 minus 2/3 x, and I'm going to graph y equals x plus 1. And what's nice is that Desmos is going to highlight these kind of points of interest, which are often the intercepts. But then when you have 2 lines, it's going to highlight the point where the 2 intersect with each other. So there we can easily click on that 3, 4, so we can double check that we have our answer right. All right, let's do one more example with graphing. So with these ones, these are given in standard form. So when I refer to standard form, that's this ax plus by equals c form. So what we want to do is change these to slope-intercept form so that we can graph these easily. So we want to change them to y equals mx plus b. So I'm going to take this 4x minus 3y equals negative 18. Actually, okay, I'm going to show you another way. Just because we did slope-intercept up there, I'm going to show you a slightly different way. But what we could do is solve this for y and then have our slope and intercept. I'm going to show you a quick other way to do it too. 2x plus y equals negative 4. So making a quick table of values and knowing that we only need 2 points to really graph a line, what we could do is find the intercepts. So when x is equal to 0 and when y is equal to 0. And these typically can be pretty quick to solve. So like if I plug in x equals 0, then we would have negative 3y equals negative 18, divide both sides by negative 3, and that'll be a positive 6. So that right there gives me one of my coordinates. Then if I do the same thing, but plugging in y equals 0, so that's going to leave us with 4x equals negative 18. This isn't going to be the prettiest one, but that is x equals negative 9 over 2, or x equals negative 4.5. And with that, we get 2 coordinates to graph. So we have 0, 6. And we have negative 4.5, 0. So there we go. So this could be a quick way of getting 2 coordinates out, and then it's just a matter of connecting them. Now this one we'd want to be careful. So we'll see how this turns out. I might end up using slope intercept since we got a decimal out there, because that's the tricky part with these graphing values, is that we need to be as accurate as we can. All right, so there's one of them. Now let's do the same thing for the other. So just a quick table with x and y. We're going to let x equal 0, and then a second case where we're going to let y equal 0. So if we set x equal to 0, we're just going to get y equals -4. If we set y equal to 0, so 2x equals a -4, so x is a -2. All right, this one isn't too bad. So 0, -4, and then -2, 0. Actually, this is a nice one where we can see a trend. So let's see, I went left 2, up 4. I'm going to go left 2, up 4, left 2, up 4, and follow that trend. All right. And this one's pretty nice. It ended up working out pretty well. I was a little nervous about that decimal there and being able to graph that accurately enough, but we see our intersection point. And I mean, our intersection points could be weird fractions not landing perfectly on the grid, and that's kind of the flaw of this graphing method of solving, is sometimes it's difficult to read and we need the algebraic way of solving. But this is nice. It's a -3, +2. So that would be our solution. So the solution is -3, +2. I'm going to go ahead and just check quickly with Desmos, because with Desmos we can just type this in that standard form that was given to us. I'm going to type in that 4x plus 3, or sorry, -3y equals -18. And then my second equation was 2x plus y equals -4. And there we see our intersection point, and it's -3, +2. All right, so that's our routine for solving graphically. We're going to graph each of the lines. You can use the slope-intercept method. You can use the x and y intercepts to get a graph of the line going. And then our goal is finding that intersection point where the two lines overlap with each other.